Question number 1. So this is a question from January 2020, not January 2022, I mean October 2022. This I'm uploading based on the poll that I have created, and it's based on my subscribers' request. Okay, so question 1, as I mentioned, a student investigated the magnetic field produced by a current carrying coil A. She made coil A by wrapping a wire around a plastic tube. Coil A has connected to an alternating power source. A second coil B was placed in magnetic field and connected to an oscilloscope as shown. Describe one safety issue and how it could be dealt. So main problem you can see here it is. What problem did you identify here? What issue did you identify here? So especially if it is if you are observing this power supply and the wire that is connected to coil A, there may be a chance there could be a short circuit across the power supply. So how we can avoid this? We can use insulated wire. That is one possibility or one possible answer. Or we can say there is a risk of electric shock. So use a low potential difference energy source. Or we can say there is a risk of wire overheating. So use a low potential difference. So these are some of the pairs of answer you can mention here. So anyway, I'm writing one model answer here. So describe one safety issue and how it could be dealt. So what I'm trying to do, what I'm trying to write there could be a short circuit across the power supply. So to avoid, use insulated wire. Clear? Question number B. The distance R between the two coils varied between 2 cm and 10 cm. Explain why using vernier calipers would be better than a meter rule to measure R. You should include calculations in your answer. Okay, it's a 3-mark question. So we can say, if you're comparing a vernier caliper and a ruler, the resolution of vernier caliper is higher than a meter ruler. That is the main point we should write. The resolution of vernier calipers is higher than a meter ruler. Clear? Basically, if you are speaking about the resolution of a vernier caliper is 0.1 mm, and the resolution of a meter ruler is 1 mm. So we need to mention, or we need to state based on the calculations. So we can say the resolution of vernier caliper is 0.1 mm and resolution of meter ruler or meter rule is 1 mm. Therefore, percentage of uncertainty for vernier caliper is the resolution by 2. That means 0.1 divided by 2. 0.1 divided by 2. This is in millimeter. So we need to convert this into meter by multiplying this with the ten to the power of minus 2. Then you multiply it with 100. So if you're doing so, you will get 0.25 percentage. The percentage of uncertainty for meter rule is anyway 1 mm. 1 mm by 2 is 0.05, right? So 0.05 by 2, 0.05 divided by 2 into 100. That is 2.5 percentage. Clear? So this is the percentage of uncertainty for vernier caliper is, the resolution is 0.01, but if you want to find the percentage of uncertainty, it is 0.05 divided by 2 multiplied by 100. That is 0.25 percentage. So from this calculation itself, we can say which is the effective one. Obviously, the vernier caliper is the effective one. The uncertainty is very less for vernier calipers. Clear? Okay. Now, question C. When the AC power supply was switched on, an EMF E was induced across coil B. The variation of E is shown on the oscilloscope screen below. One division. The Y scale was set up as 100 millivolt per division. Describe how an accurate maximum value of E can be determined from the oscilloscope screen. So it's a 3-mark question. So how will you answer this? So first of all, you measure the amplitude of the trace in divisions. So what is our aim? How we can accurately measure the value of E from this oscilloscope screen. So we can say measure the amplitude of the trace in divisions. Then what we should do? We know that it is each is 100 milliwatt. So multiply by 100 milliwatt per division. Now we need an accurate value. The last thing we can do is repeat the amplitude measurement and calculate mean. So repeat the same thing and then you take the mean of this. Okay, so the last question. of question number 1. The student measured values of R with vernier calipers and determined corresponding maximum value of E. The student's value are shown in this table. R2, the E value 320, when R4, E value 40, R6, 11.9, R8, it's 5. Criticize the recording of this data. 2 marks question. So you can see the significant figures are not consistent. So that is one problem. So we can write it as inconsistent significant figures for E. That is one point. Next. You can see for 2 only one value of 320. You can see no repetitions. You can see here. So no repeats are shown, or not enough readings are shown. So these two things really affects the genuinity of this reading. Clear? So that's the idea about